Alright, so here's your homework on limits. It says write the end behavior of each function in limit notation. So the limit as x approaches infinity of f at x, the right end is going to infinity. The limit as x approaches negative infinity of f at x, the left end approaches infinity. See if I can create enough space here. I'm going to do it like this. So for number 2, here's the right end behavior. So the limit as x approaches infinity of f at x, the right end is going up. On the other side, the limit as x approaches negative infinity of f at x. This is approaching a number. This is an exponential function, so it's approaching negative 4. No, 1, 2, 3, negative 3. Here, ignore the middle. It's the ends we're looking at, so the right end and the left end. So the limit as x approaches infinity of f at x, the right end is going to negative infinity. The limit as x approaches negative infinity of f at x, the left end goes up to infinity. All right, estimate each limit if it exists using a table or a graph. What I'm saying is if it's continuous at that number, if there's no discontinuity, and how we know that again is by looking at the denominator if there's a fraction. So in this case it's a line, it's continuous, we can just evaluate at the number itself for the evaluation of the limit. So evaluate at negative 2, and the answer is 11. Again, it's continuous, it's a parabola. There's no fraction, no variable in the denominator. It's a quick way to tell. So evaluate at 1, and you get the answer negative 6. Again, evaluate, there is nothing that makes this undefined. So evaluate at 3. And that gives you the answer 0. Number 7, if I evaluate at negative 1, 4 times negative 1 plus 4, well, if I evaluate at that, I want you to notice that it's not continuous at negative 1. So let's go and use a table for this one so you can see how that looks. And look at the graph too. So let's look at both. So we have f at x equaling, again, what's the function again? X, make sure I do this right. X subtract 3, oops, start with a fraction. All right, so x subtract 3, and then 4x plus 4. And so if I look at it, I want to know what's happening as x approaches negative 1. So at negative 1, I see an asymptote. So that already gives me a concern. If I do a table, and I call this x, and I call this f at x, and then I put in numbers that are close to negative 1. So if I go from one side, it'd be like negative 1.003, negative 1.002, negative 1.003, oops, that's not 001. This is not approaching an answer. It's getting larger and larger and larger. So if I put in numbers that are close to negative 1, I just want you to notice that this answer is getting closer and closer to infinity. And if you look on the graph, you can see the left side of negative 1, that the graph is going to infinity. On the other side, so if I did like negative 0.999 or negative 0.998 or negative 0.997, I want you to notice that this is also getting closer to negative infinity, that they're not agreeing what the answer is. So on one side and on the other side, now if I said just negative 1, you know it's undefined. But notice we have an asymptote anyways. It doesn't exist. There's the short answer to it. For number 8, is it continuous at 5? It isn't. So if you plug in 5 for x, you get the answer 0. So let's try this one on a graph. So I'm plugging in x squared, subtract 4x, subtract 5. In the denominator is x squared subtract 11x plus 30. And what I want to know is what's happening as x approaches 5. So if I did a table, oops, will this still work if it's above? I think it will. So at 5, we know it's undefined. So if I go from one side, so 4.997, 4.998, 4.999, it looks like it's getting closer to negative 6. Oops, I've had an extra 9 in there. And we know at 5, it's undefined. How about on the other side? So 5.001 or 5.002 or 5.003. So if I look coming bottom up, it's also getting closer to negative 6. It's approaching the same number on both sides of where it's undefined. And if I look here at positive 5, I just want you to know that it is getting closer right here to negative 6. So right there, it is undefined, but you can tell that if you look at the y value right there, the y value there is negative 6 as an answer for the limit. For number 9, if you plugged in 6, I just want you to know it's the same function, but when you plug in 6, there's an asymptote at 6. So because of that, this one doesn't exist. So if we looked off the same graph, notice here at 5 we're good, but if I go over 1 to 6, it's not going to be the same. So if I looked here, at 6 it's also undefined. So if I went 5.997, 5.998, notice how here it's getting closer to negative infinity. And then on the other side, it's getting closer to infinity. They're not approaching the same number on both sides of 6. Therefore, it does not exist. All right, number 10, negative 2. So if I look at that, if I plugged in negative 2, it's not continuous there. So I'm going to use a graph to understand the limit. So I can't evaluate at negative 2 because I'm not going to get an answer. So I need to look off the graph. So I'm going to type this in, f at x equals, and again it is x cubed plus 8. And then in the denominator is x squared subtract 4x subtract 24. And then if I did a table, well, first of all, if I look off the graph and find negative 8, is that what I'm looking for? Negative 2. So if I found negative 2 on the graph here, see where negative 2 is? What's the value that it's approaching? I want you to notice that it is approaching 0. My phone is going crazy here. All right, so it is approaching 0 looking off the graph. If I did a table of values, you'd also see the same thing. So whether off a graph or a table, you can see the answer. So for number 10, the answer is 0. Number 11, if you plug in 3, this one is continuous at 3, and you get the answer 1. Right? No, it's not continuous. So you'd have to use a graph again. So x squared subtract 2x subtract 3. In the denominator, 4x squared subtract 20x plus 24. And then we want to know as x approaches 3. So as x approaches 3 off the graph, it's undefined there, but from the left and from the right, you can see it's getting closer and closer. And off the graph, you can tell the y coordinate there at that hole is 1. So from the left and right, the y value there is 1. That's what it's approaching. For number 12, to evaluate at 0, you can plug in for x and you get 16 over negative 20. Or you could write that as negative 4/5. For number 13, as x approaches 1 for this, let's look at that. Absolute value of x subtract 1, x subtract 1. So what's happening at positive 1? So at positive 1, there's a jump right here. So from the right, the answer is positive 1, and from the left, the answer is negative 1. So there's a jump right here at positive 1, so therefore it doesn't exist, the limit. So the limit doesn't exist at a jump. Here, we're going to evaluate. This is continuous at 2, so just plug in 2 for x and evaluate it. So 16 take away 4 is 12 divided by 4, so the limit there is 3. If I look at number 15, I need to use both the top piece and bottom piece. So negative 2 into the top piece, negative 2 into the bottom piece. Both answers give me negative 8, so the limit is that, because they agree on the answer, the top piece and bottom piece. The value of the limit at 0, this answer is 1. That's the value there. You can use a calculator to calculate it. At 3 pi over 2, tangent has an asymptote, therefore it doesn't exist. At pi over 2, sine is continuous. There's no breaks or jumps or anything like that. The value of sine at pi over 2 is at the top of the unit circle. It's positive 1. So 4 times positive 1, and the answer is 4. A couple more left here. What's the value at 0? If you put this into a graph, pi over x, it's undefined at 0. It's going to oscillate around it, so therefore it doesn't exist. To plug in negative pi, it's continuous. So negative pi plus pi is 0, and the value of sine at 0 is 0. If I look at 21, again, at pi over 4, it's continuous. No asymptote there, so I can evaluate where it's continuous. So because it's continuous, the 4's divide out, I get pi. The value of tangent at pi over 4 is positive 1. So pi divided by positive 1, and the answer is pi. All right, Mr. G Math over and out. Thank you for doing your homework with me. Until next time.